That's fine. Huh. I see. All right, if I could have everyone's attention, please. So let me try this again, see if this works better. So we previously had this example with that bank account class. Oops. That's interesting. I don't even have to. That's no good. And I just do it differently. One day I'll figure this out. So we had the bank account class. I hate this hardware. No, it doesn't do anything. Okay, now it'll work. Alright, so we're at the bank account. Now we had the coin class, then I tossed in the candidate. And then I said, let's modify them all so that they implement this interface called measurable. Hey, how about we don't have too many people talking at the same time? All right. So that was so when I draw this in this UML notation, I say bank account, coin, and candidate. They all implement this measurable class. And for implement, you have the special kind of arrow that's a dotted line and has a triangle at the end. So why do we do that? The reason is that now we can have the dataset class, which. Gosh, this is frustrating. We have the dataset class, and now the dataset class uses the measurable class. If you remember from last time, what does uses mean? Does anyone remember what uses means? Section 8.1? 8.2? So what does it mean for one class to use another class? Yeah, dependence. Good. So in plain English, it means it's aware of its existence. It makes use of it in some way. And we'll look at specifically in how it makes use of it in just a minute. So the dataset class, I assert, uses the measurable class. Well, actually, let me show you how it uses it. It's easy enough to see it. So here's the dataset class. How does the dataset class use the measurable class? Excellent. It calls getMeasure on an object of that type. It calls a method of that class. So over here, it has this object, it receives it, and then it calls a method on it. Okay, that's pretty much what using is all about. You call some method on that object. So the dataset class is aware that the measurable interface exists. Now if I go back to this diagram here, the dataset class, does it use the bank account? Let's find out. Does it use the bank account? No, there's no mention of bank account anywhere here, right? And it doesn't use the coin, and it doesn't use the candidate class either. So in this way, the dataset can provide a useful service. It can compute maximums and minimums, and sums, and averages. And it can do that without ever having to know what these classes are about. That is the prime benefit of using an interface. With an interface, I can decouple this class that does something useful from these various classes with which one wants to do something useful. Also note that and none of these classes know anything about the data set. They don't really know why they implement the measurable interface. They just do, and then some other application programmer says, therefore I can process them with the data set. So you have this somewhat abstract notion that we design an interface so that we can make a calculation without really knowing what calculation we're making. If we just know how big some things are, then we can find out what's the biggest. And so we need to have that kind of notion. That sounds a little bit abstract, and maybe it is, but it is awfully handy because there are many different situations where this kind of basic knowledge is enough to write an algorithm. Let's go a step further. Could I make something that it sorts an array of measurables? Do I have enough information to sort them? Sure. Yes, that's sure. And absolutely, right? Because all you need to know is how big is each item, and then you sort them largest first, smallest last. How do you sort an array? We actually haven't covered that. Just checking whether any of you. But if you have to sort one, how would you sort it?
Like just go through it, like iterate.
Well,
Move each element or something.
yeah, but how do you know where to move it to?
You check each element as you go through it.
Against whether it's bigger than the neighbor?
Yeah, like basically.
Yeah, you have to do it multiple times, and we're going to learn that next semester. But I'll give you a really easy way of sorting an array. You find the largest element, and you know how to find the largest element, and you move it to the end. Then you take all the others and find the largest and move it to that end, and so on. So we know how to sort. It turns out that's not a very good sorting algorithm. There are better ones, but that's the topic of next semester. All right, so sorting could also be done just with measurables. You wouldn't have to know anything else. In the lab, we're going to find another approach. And let me just show that because I think it'll be more interesting to see that. This will be Lab 12, the last lab of the season. In Lab 12, we're going to come up with an interface called Drawable. And I'll peek ahead and probably take all the fun out of the lab. No, it doesn't even say. Here's the car class, which isn't very interesting right now. Where the heck is the car component? Here. So in the car component over here, sorry that's so small. I'll have to adjust this next time to get bigger. Over here, notice how it calls the draw method on the car, and then the car shows up on the screen. It's a method of the car class, and this particular program can draw cars. Well, what if you want to draw something else than cars?
Like dogs.
Yeah, like dogs. You know, like children. Like a ball. You know, the car coming dangerously close. That kind of stuff. And so, a typical suburban scene. So in that case, you want to be able to call draw on a whole bunch of different classes. So you would have a class, dog, and a class ball. And all of those would have to have a draw method. And you have car, of course, has a draw method. And now I want to make a whole bunch of these objects, and then I call draw on all of them. So I would want to say, for I goes from 0, I less than objects.size, I plus plus. Then I pull out the ith item, so item equals objects.getI, and then I want to call item.draw on the graphics. So I want to have like a universal draw method that works on all items. And that makes sense, right? You want to draw all the items in that collection. Just like in the previous one, I wanted to call, what was it? Get measure on a bunch of different things. What's the type of item? So over here you see this value item. That's I pull it out of the array of objects here. It's the ith one of them. And now I call draw on it. And it's an object. And in Java, every object must belong to some type. Right, you say string something. Except can it be a string? Can it be a string?
Yeah.
He says yes, with courage. But he's wrong. Why can't it be a string? Why can't it be a string? Yes.
Well, one in the for loop, you can't call dot size on.
No. The dot size, I call an object on the array of objects, or the array list of objects. So the dot size is not called an object, but
Just draw.
so let's take the second reason, and that is on the item I call draw. Does a string have a draw method? It does not. Okay. So because it doesn't have a draw method, it can't be string. What could it be? Give me some type that does have a draw method.
Perhaps.
What?
Perhaps.
I'm sorry?
Perhaps, I said.
A perhaps.
Yeah.
Okay, we're going to have a perhaps. So give me some type that has a draw method.
Ellipse.
Okay, that's actually a good idea. Ellipse might have a draw method. We'd have to look it up. It might have one. Yeah, you have a type that has a draw method?
Rectangle.
Rectangle. Okay, same answer. I'd have to look up whether it has a draw method. Because we always call it the other way around. We call the graphics dot draw, and then we put in the ellipse. So I don't know if you can convert it the other way around, whether you can say ellipse dot draw and then put in the graphics.
So is this a trick question?
No? It's a question of, can you look at the board? Exactly. Car has a draw method. Right? So I could make it so that item is a car. Right? Then the draw thing would work, but there is, no pun intended, a drawback in that approach. And that is that then it wouldn't work for ball and dog anymore. So I need to find something that a dog and a ball and a car, they all have the same common type, and that's where the interfaces come in. I would have to make an interface, and that are called drawable, and that thing has a draw method, and then the dog and the ball and the car would have to implement that interface, and then down here I can put drawable. So that's the other need for interfaces, that you want to have a common supertype for these various different types. That you want to have like a lowest common denominator, so you can refer to all of them by that capacity. You can say they're all drawables. This is a new feature that we've never seen before, where you can classify these different classes. You can put them into some systematic arrangement called an inheritance hierarchy. So we're going to say that a car is a special case of drawable, a ball and a dog. They're all special cases of this drawable type. Alright, now should I go on with the drawables or should I go back to the measurables? Alright, we have a vote for drawables. Okay, yeah, I like the drawables better myself because they're kind of more visual. So the last observation that I want to make is, so I have this loop here. Oh, that's so annoying. Okay, whatever. So I have the You would hiss too if you had to deal with this thing. Okay, now we're good. So we had drawable item equals those various objects dot get I, and then we had item dot draw, and then we had so that was in the component class. Then we had a class dog, and it had a draw method, and then we had a class car, and it had a draw method. And I can show you the draw method of the car somewhere here. That's the car component. Here's the draw method of the class car. You may remember this thing, the car. It has wheels and a front and a rear, and you laboriously draw, all of that stuff. So that's that draw method. I don't even want to begin to imagine what the draw method for the dog looks like. I will not torture you with my rendering of a dog. So, so you have these different draw methods. So here you have this loop, and it picks out an item and it calls draw on it. Now let's say I'm going through the loop, I'm finding my first item, I is 0, and I call draw on it. Which draw method is called? What was that? Say it again. So he said, whatever one it is that the first one was. I grabbed an item. I don't actually know what it is. It could have been a dog. It could have been a car. It could have been a ball. All I know is it has a draw method. And then it'll find its way to whatever that object was. It'll just pick the correct draw method. It does exactly what you think it does. It has an object. That object has a draw method. And the correct code of whatever that object is has as its draw method. That code is just going to run and draw some shape and it'll show up. So this sounds like it's exactly what should happen, and it turns out that it's a little difficult for the computer to make this so. It has to what does it have? It has a reference to an item that follows up to some object, and in this object we don't actually know what kind of object it is, but we do know it has a draw method. And so it has to follow to the object, it has to invoke that draw method, and it just does that. Intuitively it's simple enough, but because it's complicated to implement, it has a special name. This thing is called polymorphism. Polymorphism simply means it calls the correct draw method. It calls the draw method that belongs to the object. If this happens to be a dog, then it calls the dog's draw method. If it happens to be a car, it calls the car's draw method. It is not a difficult concept. It's just they had to work on making it work so nicely. So when you see polymorphism, all it is that concept of that it calls the correct method. So now you know everything that you need to know about working with interfaces. So an interface has one or more methods, oftentimes just one, but it could have more than one, that express some common behavior. And it's often difficult to come up with a good interface, but it's something one learns over time. So it's common behavior, and then you have one or more classes that provide concrete implementations for that. So this is a long lab, so I don't want to lose time in it. So go ahead and get going with A and possibly B. So certainly do A. Let's all get to A and let's see how far we get. If you have extra time, do B. Did I give a Dropbox for this?
For 12? Yeah.
For today?
1:30 p.m.
I'm a genius. Okay.